Hello everyone. Today we are going to discuss about Igbt characteristics using a Pragna study unit. Here we have used Igbt, which is IRGB CS20S. It is the front panel specification has been given. Next, it is the main circuit and specification of the Igbt has been given. In this circuit, uh, as you all know, Igbt has a three leg, which is gate terminal, emitter terminal and a collector terminal. In this, the gate terminal is connected to the variable power supply V2, which is the positive of the V2 is connected to the gate terminal and a negative is grounded, and VGE, which is voltage across the gate and emitter, is measured using a voltmeter, which is 0 to 20 volts has been given. So we will connect here. Then the emitter region is grounded. Then the collector region is connected to the milliammeter, which is 0 to 2 amps. The negative of the milliammeter is connected to the collector region of the Igbt. Then the VCE, which is connected across the emitter and a collector region, which will measure the voltage across the VCE, which is rated about 0 to 200 volts, and the positive of the milliammeter IC is connected to the variable resistance RA, but it is not variable resistance in this circuit, which is constant load resistance which cannot be varied. Next, the positive of the RA, there is no positive negative for the resistance, but positive has been connected, so negative connection will be connected to the positive of the V1. Then negative connection of the V1 is connected to ground. The circuit is this. First, in this transfer characteristics of the Igbt, we will know the procedure has been given. You can take the screenshot and read it. In this the tabular column, we will make sure the VCE is constant for about 10 volts, and we will vary the VGE and IC with respect to it. For transfer characteristics for Igbt, it will be like the ideal characteristics graph is this. We will plot the graph across the IC and the VCE. We will make sure that VCE is about 10 volt constant, and VGE and IC is varied with respect to the time. Okay. Now in this, the circuit connection has been made shown here. Please note down that these are common, internally connected, and this also. It is the Igbt main circuit, which is the collector region, emitter region and the gate region. The gate region is emitter region is internally connected, and collector region is also internally connected. And here positive, which is V2, and this is V1 in the circuit, V2 and V1. Here this is V2, and these are also internally connected, these are also internally connected, same goes here. Okay, we first in this, as shown in the tabular column, we are make sure that VCE is 10 volts constant. Okay, VCE has been 10 volt constant, which is VCE nothing but the voltage across the load, or this we will considering this. So they have been given that VL. We make sure that it is approximately 10 volts. Then we will vary VGE volt and ICE with respect to time. Okay, if we vary the VGE with respect to IC, we will get the values with respect to this, which is 10. VCE is constant for 10 volts, and with respect to VGE, the IC will vary. For the ideal characteristics, it will be gain constant. Up to some region, up to some point, it will increases and it will gain constant voltage. Constant current. This is tabulated for 10 volt and 20 volts. If we come to the circuit here, if we vary very slowly, for 2 it is 0, 3 it is 0, and it increases. As we increase the voltage 5 volt, it will show some approximate voltage, and VL also decreases with respect to it. We will increase it up to 10 volts. See, across 6 volt, the 79 milliamps is constant for IL. As we increase the VG, it will not increases because it has reached its maximum amperes. So this is the transconductance characteristics of the Igbt. Next, we are going to discuss about collector characteristics of the Igbt. Here, this is the procedure. for the same circuit we are going to make sure the constant of VGE for 5.0 volts. Then we will vary the VCE with respect to IC in milliamps. Okay, in this collector characteristics of the IGBT, we are going to tabulate the column here. Please note down VGE, which is given that 5 volt. Please vary it with respect to your configuration. In our configuration, we are going to set for about 5.6 volts VG. See, if we vary the VG for 5.6 volt, for VCE with respect to time it will vary like this. For IC in milliamps it will vary like this. The graph is like about like this. From 0 it will increases gradually, then the voltage will be constant for some value, then it will increases. See, the current is varying with respect to voltage. For some time it will be like this, then it will be constant, then it will be raises gradually, it will increasing with respect to time, it will increases. So we will make sure the constant of this VG is constant for approximately 5.6 volt for our circuit. Then we will vary the VL. If we vary the VL, see, the IL also varies. You have to vary with respect to VL is varied with respect to IL very slowly, so you have to take the tabular column. This is the video about IGBT, whose trans characteristics and collector characteristics. Very easy. Thank you.